formula is limit x tends to 0 sin x by x that is equals to 1. Okay, so there is two approach. First approach is if x is very small, then sin x is approximately x. Okay, so our first approach is if sin x or x is very small, then sin x is approximately x. So what we get? We get limit x tends to 0 x by x and that is equals to 1. Okay, that is our analytical approach. We have to know the series of sin x, that is x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial and so on, right? So if we put that value, what we get? We get limit x tends to 0 x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial and so on. So we get by x, so we get limit x tends to 0 1 minus x square by 3 factorial plus x to the power 4 by 5 factorial and so on, right? So we get the value 1. Why? Because x square, which is very close to 0, whole square, it is nearby close to 0, right? If we take to the power 4, it is more closer to 0. So we take it as 0. So that's why without 1, all the values are eliminated. Okay. And if you think you calculate all the values, so you get 0.99999. It's very close to 1. So that's why we take the value that is 1. So this is our first formula. There is another formula like e to the power x minus 1 by x limit x tends to 0 that is equals to 1. Right? You have to understand the series of e to the power x. E to the power x series 1 plus x by 1 factorial plus x square by 2 factorial plus so on. So limit x tends to 0, 1 plus x by 1 factorial plus x square by 2 factorial and so on, minus 1 by x, 1 and 1 eliminated. So if we divide by x, what we get? We get 1 plus x by 2 factorial, x square by 3 factorial and so on. So it is 1. What is the logic? Logic is same, but is previous logic, right? So there is another formula we discussed, that is limit number 3, x tends to 0, logarithm of 1 plus x by x, that is equals to 1. We have to prove it using the same rules. Okay, so we take two examples and try to find the value. Okay, so suppose there is a mathematics like limit x tends to 0, e to the power 5x minus e to the power 3x by x. How we solve that? We know the formula e to the power x minus 1 and e to the power x minus 1, right? So we do that like limit x tends to 0, e to the power 5x minus 1 minus e to the power 3x minus 1 by x. Minus 1 and plus 1 eliminate. Okay. Now what can we do? We divide into two parts. Okay. We divide into two parts. So we get limit x tends to 0, e to the power 5x minus 1 by x minus limit x tends to 0, e to the power 3x minus 1 by x. So that is 3x. That's why we put 3 and multiplied by 3. That is 5x. So we put 5 and multiplied by 5. Now we have to know that the limit x tends to 0, e to the power x minus 1 by x equals to 1. But in that case, that is e to the power 5x minus 1 by 5x. So our limit should be 5x tends to 0. If x tends to 0, then 5x obviously tends to 0. Similarly, in the second case, it is 3x tends to 0. So we get that value, that is 1 multiplied by 5 minus 1 multiplied by 3, that is equals to 2. That is a very basic problem. Okay, now we take another example. Limit x tends to 0, e to the power x plus e to the power minus x minus 2 divide by x square. Okay, so how we solve that problem? There is e to the power minus x, right? E to the power minus x. So that is the problematic part we have, right? So first of all, we use that formula like x to the power minus 1. that is 1 by x, basic indices formula. So we write it as e to the power x plus 1 by e to the power x minus 2 by x square. So we get limit x tends to 0, e to the power 2x minus 2 e to the power x plus 1 by x square into e to the power x. So we write it as limit x tends to 0, that is e to the power x minus 1 whole square divided by x multiplied by 1 by e to the power x. So it is equals to 1 into 1 by e to the power 0. So e to the power 0 is 1. So we get the value that is equals to 1. And now we discuss about if limit exists or not. It is a very important part. So we take an example. We take an example that is limit x tends to 0 mod x by x. What is the value? So if we take the left hand limit, that means limit x tends to 0 minus mod x by x. So we have to know that mod x is always minus x when x less than 0 and plus x when x greater than equals to 0. And if we take x tends to 0 minus, that means it is very close to 0, but it is a negative value. So when it is negative, modulus of x is equals to minus x by x. So we get the value minus 1. And when we take right hand limit, that is limit x tends to 0 plus mod x by x. So limit x tends to 0 plus x by x is equals to 1. So you see, left hand limit and right hand limit are different. So if they are different, then we write it as limit doesn't exist. Okay, so that is a basic introduction of limit, whatever we done in today's class. And I think you understand, and we discuss more about limit in the next class. Thank you.